conseguimos aproveitar a oportunidade.
A janela, não é? Agora a janela.
Sim, the time slice na janela. Hello, good morning. Erastus. Let's just adjust the sound. Are you? Yes. Are you hearing us?
No. We
need the sound. Yes, but the problem is that I have a VGA. I should have a HDMI.
Estou a aumentar o microfone do alto-falante. Ok. Não é preciso.
Could you please say something, just to test?
Yes, I can say something.
Okay.
Yes.
Are you hearing me?
Yeah.
Okay. So, thank you very much. Just a small introduction. Maybe I'll shut you down, Erasmus. É melhor reduzir ou eliminar o som dele enquanto faço a apresentação. We are very pleased. I'm going to make the presentation in Portuguese because I think that maybe in English it's better because with the sound very low he can hear me. So it's more nice from my side to make this presentation in English. We are very pleased to include in our program, in our Industry 4.0 program, a talk by Dr. Erastus Philos, who is a person that I know and I admire for more than 20 years. It's someone that contributed a lot to defining and shaping and coordinating the industrial projects based on ICT targets to industry. Dr. Erastus Philos is Officer of the Research and Development DG at the European Commission for more than 23 years. During this time, he participated in the scientific and technical review of European research programs activities. His experience is based on more than 100 R&D projects with international stakeholders from industry and academic research. I would highlight his function as coordinator of R&D programs within the European Commission Framework Program related to the intelligent manufacturing systems during 2000 and 2012, more or less. 9 years of Factory of the Future, Achievements and Outlook is the topic of Dr. Erastus Philos. And this is a quite interesting topic for this last day of intense work on Industrial 4.0, Industry 4.0, and the fourth industrial revolution and the enabling technologies. So, Dr. Erastus, thank you very much for accepting our invitation and for being here with us today. At the same time you speak, I try to put your PowerPoint slides. Okay?
Thank you very much. And I'm also pleased from my side to be counted as one of your invitees to this forum. I am happy to be able to present to you the status of activities that we have launched and also following up during many years at the European Commission. The activities are very much linked to industry, and of course ICT has a great role to play for Industry 4.0 turn to the next slide. My presentation outline. I hope you all can see the slides. My presentation outline is about how to add value to manufacturing in Europe. This is actually what Industry 4.0 is about adding value to manufacturing, and technological innovation and ICT is driving Europe's reindustrialization, but not only Europe, worldwide. The factories of the future is a public-private partnership that has been set up between the public side, the European Commission, and the industrial industry side, the private side. That's European industry. Over now 9 years, the program has been gaining momentum and is quite well known, as you will see from the slides right now. It has already led to some very promising results. And last but not least, I will say something about the platform-based manufacturing that is we see to be the future for Europe's manufacturing. We can turn to the next slide. Manufacturing matters because it is about 16% of European GDP. That's not in every country like that, but overall it represents 16% of the GDP. And last but not least, jobs are dependent on that. 20% of direct jobs are in manufacturing and related industries, and twice as many of indirect jobs in services and supplier jobs are connected to that. So it's a very significant factor. Also, 66% of private EU R&D and innovation investments are being made by this sector. And this is something that cannot be overlooked easily. Europe is depending on the global economic system, so it is a supplier of high-tech in the area of high-tech products and expertise worldwide. Europe's products are very much valued and esteemed for their quality, precision, and reliability. So all these factors make manufacturing a very strong area of economy that Europe's economy is dependent on, and Europe's jobs are dependent on. Next slide is about showing how much Europe's manufacturing is sharing across the world. We have, if you look at the two figures on top and on the bottom, represent the figure of 2003, the year 2003, compared to 2010, a crisis year. But nevertheless, you can see that Europe's share in global manufacturing has increased from 30%, which was the largest part, to 23% in 2010. And if you look at the details of the European share, here you can see some countries striking out. Germany, for example, has a large share that stays at the top. France, UK, Italy are also great contributors, and the UK, of course. Portugal has also a significant share, but it's not mentioned here in particular. It's somehow lower, a bit lower than Spain's share, the share of Spain. So what is important to note is that Europe's manufacturing is still a dominant player worldwide, despite the rise of China. and the rest of the world, which have grown their shares worldwide significantly over the years, but Europe still remains a hard player. The latest decision by the US president to block or to impose tariffs on steel and aluminum are a sign that the US want to play catch up because they see that their share in global manufacturing is decreasing over the years, and they want to try with these measures to raise their share again. It is doubtful though whether this is something that will succeed in the end, because trade war is something that is not going to be beneficial for anybody worldwide. So if we turn to the next slide, the Industrial Revolution, this is where the Industry 4.0 got its name from. You all have seen, I guess, my predecessors in the presentations. They gave, they mentioned this diagram, the first industrial revolution, the second from mechanization going to mass production, the conveyor belts and the factories that have been introduced until the 1950s, and we got a strong increase of productivity through automation in the third industrial revolution that was introduced in the early 60s and in the late 60s rather than 70s, and this can of course be significantly increased by networking on the shop floor and networking of the devices, the ICT, driving the paradigm of manufacturing, making products and machines interconnected. And this is something that is going to reflect a major revolution in the way we do business, and we offer services on top of that. If we can move to the next slide, the manufacturing of the EU 28 countries is growing in its share, or rather employment is growing in the high-tech and medium-tech manufacturing sector in Europe, and this is thanks to innovations and ICT that has become an important part of the manufacturing paradigm in Europe. We turn to the next slide. You can see the figures here showing that the employment of ICT specialists in the EU in absolute terms and as a share of total employment is growing. So there is need for expertise in ICT and in artificial intelligence into the future. And this is a major characteristic of the European projects worldwide that is going to determine the competitiveness of Europe's manufacturing industry. If we turn to the next slide, we will see also that this goes together with the workplace trends. The workplace 2020 is characterized by complex, networked environments, open and flexible and virtual, like our forum today, which is virtual. I guess most of the speakers have been connected, and also the listeners to these presentations are all remote and connected via ICT. And this is a typical characteristic, despite the difficulties of setting up those systems and operating those systems, the security issues involved, and so on, is going to be a dominant characteristic of the workplace in 2020 and beyond. The requirements for workers, for people in the workplace, are going to be adaptability, multidisciplinarity, and creativity. This is not my that are advising the European Commission on the matter of the skills in 2020 that will be needed. One of these characteristics is ICT competence. It's important that people have not only basic skills in how to run computers and to operate the computer, a computerized workplace, but also critical thinking and problem solving, apart from the social skills that will continue to be needed in the workplace of the future. So the skills issue is striking here as being ICT competence. ICT competence as a key characteristic for the Industry 4.0 paradigm. If we turn to the next slide, you can see that this picture with the three pillars, a bridge with three pillars, has been shaping the new framework program Horizon 2020 of the European Commission, because it was recognized by a high-level group at the beginning, before the program was launched, that what is missing in Europe is to bring knowledge to the market. Their bridge is broken. We are very good in Europe. We have very good universities and technical schools that are training people and giving them the skills and the ability to produce high-tech products. But all these ideas are not brought together in here, but it is actually broken, is how to go to bridge the valley of death that characterizes technological development and moving technological development into products that are needed on the market. And there, compared to other world regions like the US or China, we are perhaps not doing a very good job. So we need to cover this financially, and we need to bring our good ideas to the market in a way that the market can pay for them. So it is important that we are not only doing good research, but that industry is on board. And this is why the public-private partnerships have been set up. And these industrial partnerships need to be used or be coming into the game of receiving support in moving across the valley of death to a market that is requiring the latest and best of breed products. Now, if we move to the next slide about how to advance manufacturing. First of all, it's innovation. As I said, the new program is putting an emphasis on innovation, and in the next framework program, the so-called FP9, Framework Program 9, that is just a placeholder name for what will come after 2020 as a research program from the Commission. Innovation is going to have a central role. As you have heard, perhaps, the Commissioner for Research, a compatriot of yours, Mr. Moedas, has already set up a European Innovation Council that needs to be and receive funding in order to become an institution that is going to churn out new technology that is needed in markets and in Europe. So we are looking forward to new developments around the framework program. But if we turn to the next slide, how to advance manufacturing is also through deployment of advanced technologies. And advanced technologies are the outcomes of good research that we are doing in Europe. But you can see here a list of technologies that have been mentioned, like advanced materials, connectivity, digital design, simulation, integration, high performance computing, advanced robotics, additive manufacturing, 3D printing, open source design, and direct customer input, and so on. And these are on the right side, you can see this is what, from the study of Deloitte and Touche, is what US, Chinese, and European CEOs have voted for as important for the markets of the future. Now, if you turn to the next slide, you can see of the industrial deployment of key enabling technologies. There are a few enabling technologies that are the result of high-tech driven research, like photonics, just an example, nano electronics, like new advanced materials, advanced manufacturing, AI, artificial intelligence, and so on. And these technologies are underpinning the developments and the large product base that is built on these technologies. So in Europe, we are good at developing these key enabling technologies, but what we are not good at is providing the connection to the products that are needed on the market that is on top of this slide. So the first stay competitive. Now, what has the European Commission been doing or trying to do regarding policies? In the next slide, you see that there are two industrial policy paradigms that are driving manufacturing or impacting manufacturing. One is the digitizing European industry. I will go into more details in my follow-up slides. But also, you see the other being circular economy, a concept that is becoming more and more obvious to all, global citizens, to industry, to policy makers, that the Earth's materials are depletable. They can be depleted and they can be thrown away and becoming rare if we do not adopt a circular economy in the sense of reusing materials and preventing them from harming the environment. So it's important that industry is taking care of using the circular economy paradigm to save energy, resources, and minimize waste. If we go to the next slide, more than 30 years of manufacturing R&D in Europe. We started in 1984 with the Framework Program 1, and ESPRI and the Bright Europe programs were at the heart of the development then already. Up to today, 2018, it goes here up to the year 2014, where the factories of the future, FOF, Inspire, Spark. This is the robotics platform and robotics public-private partnership and the photonics public-private partnership that have been launched at the beginning of the new framework program. So we go to the next slide. It's about Horizon 2020 that, as I said already, is trying to put innovation in the center of the whole process, to integrate research development activities with innovative new products. So you see there is a lot of money that has been put over the 7-year framework, more than 12 billion euro every year, and research is driven very much by industrial needs. And it is also a new, for those of you who have perhaps participated in one of the projects of Horizon 2020, you have noticed that companies, universities, institutes of all EU countries are represented there, and the access for them is made easier than before. So we try from the European Commission side to make access to the program and to financing easier for the researchers in order to be efficient in what they're doing. So next slide shows the setup of the public-private partnership, FOF. There is, on the one hand, you have the public sector, which is the European Commission and the member states, governments, administrations. But on the other side, you have the private side, which is represented by a body called EFRA, European Factors of the Future Research Association. There, people are organized multi-sectorial-wise, covering all supply chains, covering many industries and research institutes. And this body is advising the Commission about what research is needed for the future, for benefiting industry. If you look at the next slide, you have the question, why factors of the future? Why is this needed? First of all, as I said already, manufacturing is a key contributor to EU economic prosperity, but also as it is a complex R&D intensive activity, requires a long-term horizon, a strategic approach. And this is provided by industry coming together and agreeing on a roadmap for research in the future. This is not only done in Europe. You see that there is public support for industry in the US, in China, Korea, Japan, our competitors worldwide. So we need to shape up also in Europe in order to ensure our industry's competitiveness for the future. So the tech capabilities and supply chains are dispersed across Europe. So we need a European approach to research, development, and innovation. And this is done by these partnerships. Next slide shows the roadmap that has been revised or updated in the Factories of the Future, PPP. They have held a series of consultation meetings between the stakeholders in this partnership about what is important as research topics in the future. I understand that not everybody can read the details of this slide, but if you have it in front of you, you will see, I guess, paper copies will be available, or copies will be available for everybody. So this roadmap for research issued by EFRA is on their website. You can go to it and you can download it to see what are the topics that have been proposed as research priorities for Europe. Next slide shows that this partnership across Europe is involving a range of organizations from all countries and industries, national research institutes, and regional initiatives. So there is a broad consensus on the need, but also a broad the realization that we need to move together in order to be able to confront the threats on the global market that are posed from other competitive regions across the world. If we turn to the next slide, you can see here the profile of the beneficiaries, how much this is typical for the public-private partnership part of the research program. You see that industry is strongly involved. Research centers and universities are there as well. Others that are mainly private or non-profit institutions and SMEs. So you have a very strong part of industry, more than 60%, if you take the large industry and the SMEs together, in partnership with research institutes and universities in Europe, doing research that is relevant for the market. Next slide shows how this partnership is measuring progress. The progress, first of all, I should say that there are more than 200 projects that have been launched in the framework, the 9 years of public-private partnership, Factories of the Future. More than 1,300 different organizations are participating, and industrial participation is more than 60%. And what is being measured is patents, standardization inputs, of course, publications. That's important for researchers, but this is not the only criteria. And also leverage of investment. So it's the public money that is flowing into this activity from the European Commission is countered by or complemented by 2.5 at least leverage of investments by industry in the market introduction of the research results. And of course, there are other goals, not only competitiveness related, but those goals that are related to a more benign development like energy use, reduction of energy use and CO2, and a footprint 20% reduction on average is measured by the projects that have been launched, and also the contribution to the reduction of waste and material use is about 50% on average. These are figures coming from the EFRA Association. Now, I would like to give you 2 examples of projects. The first one is about symbiotic human-robot collaborative assembly, technologies and innovations and competitiveness. It's a project, that has been launched in 2015 and will finish next year. It is about making robots and humans collaborate without a cage. Robots, in the first generation of robots on the shop floor were mainly for welding and heavyweight applications. And now we see robots going into all kinds of activities, learning, and in particular, sensitive to the human environment. And this is an important step to make European robotics and industrial robotics very attractive for penetration into all kinds of areas and sectors across the industry. And the next slide shows 2 other examples of how the projects are leading to more than just being used for gaining new knowledge. They are, like, for instance, the White Arm project is leading to or entering into the real industrial settings at Prima Industries in Italy, and they are triggering already investments because they are using their technology in laser welding to do all kinds of, to apply them on all kinds of products. And another project, EMC2 factory, is at Festo in Germany, where a pilot future factory is being built with 100 employees that will increase to 300 in the next 3 years at the end of the project. So these projects are very close to not only academic what is needed actually. Let me also talk about in the next slide about the progress of this partnership regarding startups. We have 3 projects, for example, the Phantom Print, the Vistron project, and the Comet project that have led to spin-offs or startup companies that are introducing new products on the markets. So this is where the research is leading to concrete results to bridge the gap that is between knowledge generation and market expectation. So the bridging through startups, through implementation of methodologies in factory environments, as we've seen, is really encouraging. And this shows that we need to move forward in this direction also in the future. Now, let me show you, because time is limited, let me show you how ICT is playing a big role here. In 2016, there was a Commission communication, which is a paper that is issued by the European Commission to advise member state governments and the European Commission services about the need for doing something in the task of digitizing European industry. So it's actually about bringing Industry 4.0 to Europe's industry. Because there are many initiatives. In Germany, it's called Industry 4.0. In other countries, it's called differently. So it is important to have a European level coordination mechanism that brings together all these national initiatives and European efforts in order to coordinate the activities and to bring about the results that are needed. So you have, on the one hand, policy elements, regulation that is needed with respect to easing data flows, clarifying the ownership and use of data, the trust, security, and liability issues. This is a political task where you need to harmonize the framework across Europe in order to have this implemented across the whole continent. But then it's also looking at what is needed in terms of skills, so the workforce that needs to be trained, skills to be making them available across sectors and across countries, of course. And strengthening the competitiveness, that's the overall goal, competitiveness in key parts of the digital value chains. So this is about the big initiative, and under this initiative of digitizing European industry, let's say the factories to digitizing the whole industry, digitizing the supply chains, and digitizing the industry. And the next slide is about moving towards platform-based factory environments. This is my ultimate thesis here. What is needed is what we need to consider life on the smartphone. You have the platform that is taking the input coming from sensors and the physical world into and linking into the virtual world of applications and providing added value for the user. So it's combining product and services by linking the real world to the digital world. And similarly, also the smart factory is about linking the various components that are loosely available, unconnected, meaning connecting them on the shop floor and linking them to the various applications that are needed for smart products in the future. The next slide shows just a few examples of open platforms as this working group on platforms of the digitizing European industry has elaborated. Here you see efforts that are open source, you can say, that are developed by European projects on the left side. You see community-led, sector-specific vertical applications, Fireware, Bitman, were European projects that have been establishing a reference architecture for factories, and Rami is the reference architecture model integration. I don't know, it is the standard that Shell tried, and it's still in the beginning. Shell tried to link the different worlds, the IoT world with the robot world, and the supply chains with the factory floor. In the middle of the diagram, you have the various innovative platforms that are being that are coming together on a horizontal linking within the factory, the horizontal activities. And on the right side, you have proprietary platforms that are used like Siemens, Dassault, SAP, and GE that are linking or that are specialized in certain tool sets and applications for different tasks across the industry. So the question for us is, if we can turn to the next slide, is how to bring the different activities to be synergistic and to lead to ultimately to competitiveness of products that can sell on global markets and that are innovative, that are secure, that are easy to use, that are attractive and can sell around. So this slide, framework of AI activities, shows actually what the partnership, what this initiative is about, all the different aspects. I don't want to go into the details here because there are manifold and time is short, but there are different aspects related to that that are covered by the research program, others that need consultation between experts and standards, and others that are about the role of universities and institutions for educational institutions for skills and job profiles and so on. If we move to the next slide, I'm finishing off. I wanted to use this slide of the circular economy also to show that industry is looking very much into that. Not only because the prices for raw materials are going up and materials, energy, and resources in general are becoming scarce, but also because the customers are requiring that products are environment friendly, that they are not going to be just thrown away, but reworked and remanufactured. So there is there are a lot of drivers to make sure that we are going to live in the future in a better world, not a throwaway product world, but a world in which innovation and ingenuity is flowing into how to make products and resources more available and better available to us all. The final slide is about further information. If you would like to see more details about the Horizon 2020 research topics on the one hand, or information on the public-private partnerships and the Digitizing European Industry page, you can find all these informations, diagrams, download presentations, all kinds of information on the sites that are given here. But also feel free to contact me personally at the email address given here. So I'm more than happy to give you information or directions to where to look for the information that you are looking for. Thank you very much for your attention, and I wish you good luck.
Thank you very much, Dr. Phyllis. I'm trying to go back to you. I don't know how. Okay.
I can hear you.
You can hear me. I hope you can hear me also. Well, we are a little bit delayed. We thought that maybe we could have some questions, but we have no time. So I would invite you to direct your questions directly to Dr. Erastus Phyllis, as he made available his contacts. And we will also give this presentation to the participants to this event. Thank you for your so well structured presentation. It was a very interesting overview, an interesting outlook of the European projects of ICT in manufacturing and insights for the major challenges of Industry 4.0 for the coming years. So the technology is there to increase productivity and boost economic growth. We were able to hear from you the major challenges, the main trends, for instance, the workplace trends, the skills, the ICT competencies, and the future of the factories, and also the priorities for Europe. So I think we are much more rich after have listened to you. So thank you very much once again for your availability this Saturday. Thank you. Muito obrigada a todos. Temos então agora o nosso coffee break, que terá de ser necessariamente curto.
Só mais uma horazinha assim, 10, 15 minutos no máximo. Vamos ter também que rever a segunda parte da agenda da revista também, mas gostamos de ter feito 10 minutos, 15 no máximo, voltamos a ver também.